Oklahoma weather is never a constant. As Will Rogers famously said, if you don't like the weather in Oklahoma, wait a minute and it'll change. But in recent years, those changes seem to be getting more unusual and more extreme. Ice storms in October, flooding rains in summer, and just about everything else in between. In this week's in-depth discussion, Susan Cadot and guests take a look at the science behind our ever-changing weather.
Right now, everyone may be complaining because it's so hot, but actually the weather has been a little different in Oklahoma and in other parts of the country. I'd like to introduce our guest to our viewers today. First, we have Dr. Harold Brooks. He's the senior research scientist at the National Severe Storms Lab in Norman, Oklahoma. And then we have Gary McManus, who is a state climatologist at the Oklahoma Climatological Survey, also in Norman. Gentlemen, thank you so much for being with us.
You're welcome.
Thanks for having us.
Well, let's talk about the weather. First of all, the first thing I would like to know is, have things been different than what they currently are? Let's start with for Oklahoma. Are things cooler? Are they hotter? What's going on?
Well, this year we're actually much cooler than normal, but most of that can be attributed to the February deep freeze that we went through, one of the most significant prolonged periods of freezing weather in state history. But otherwise, it's been a pretty cool summer as well. So we're not talking about a lot of extreme heat this year, other than some extreme heat indices or heat index values that we've had due to all the rain that we had through spring and early summer. So at least lately, nothing too bad.
Dr. Brooks, I still remember that summer where we had 110 degrees for several days on end. And it seems like, I guess I have trauma from that. So it seems like it just happened, but it's been a while since that happened. Is that a heat dome? And, I'm hearing a lot about heat domes. Are they more happening up north now than they usually did?
Well, I think they happen in different places, different years. It's the atmosphere in effect you can think of it getting stuck in a pattern. And it's once you establish something like that, wherever it is, it's really hard to get rid of it. It takes the atmosphere a lot of work to get rid of those things. We've briefly been in circumstances like that this summer in Oklahoma, but certainly the big events of the year were the Pacific Northwest and Southwestern Canada. And then what hasn't gotten reported nearly as much in the U.S. has been a really large heat dome over Siberia. That it's been incredibly warm in Siberia, and fortunately we haven't had one of those when they happen around here, in large part because of the presence of the Rocky Mountains. Summers where we get stuck like that, it's incredibly difficult to get out of it once it gets established.
Well, what is a heat dome in the first place? Really?
I mean, in effect, it's an area of where if we look at the large scale atmosphere, we have what we call a ridge. There's in effect, there's a kink in the jet stream so that the upper atmospheric flow goes far to our north, and we get a high pressure system at the ground, and associated with that, there will be a lot of, it'll become eventually hot because things dry out, and it becomes hot, and that reinforces the high pressure. And so the high pressure just sits there, and high pressure systems don't move as rapidly as low pressure systems do in the atmosphere. And in effect, you get this pattern that stays for sometimes weeks on end, and it slowly heats up.
One of the things particular about the 2011 heat wave was that we were suffering one of our worst years of drought in our history. So certainly not the prolonged drought comparable to the Dust Bowl or the 1950s drought, but probably the worst drought we had seen since the 1950s. And that's one of the things that we talked about with the Northwest heat dome they've suffered this year. They've also had extreme drought. So those droughts, those big droughts and heat go hand in hand. They sort of feed off each other. So whenever we start losing soil moisture, that sun's energy that comes down can start being used to heat the surface of the earth instead of evaporating soil moisture, which is a cooling mechanism. So one of the things that we saw during 2011 was that extreme drought, and they really did start to feed off each other. And really that drought lasted from late 2010 through 2015, we didn't see the intense heat as much as we did in 2011. But 2012 actually ended up being the warmest year on record for the state of Oklahoma. So a lot of heat came during that drought period. And again, those big droughts, they do tend to exacerbate the heat, and then the heat exacerbates the drought, and they do tend to start to become a positive feedback on each other.
And this year, we've kind of seen the flip side of the really hot and dry. In Oklahoma, you can really think of summer as we got two options. It can either be very hot and dry, or it can be not quite so hot and wet and really humid. So that this year, even though we haven't had the extremely high temperatures, we have had extremely high heat index values. And that those things, again, just like the extreme high temperatures and dry go together, not quite so high temperatures and really high humidities go together as well.
Yeah, and let's flip that to colder, because last fall we seemed, the temperatures cooled off earlier. It was cooler in October. Normally I say we don't start cooling off until about the second week in October. Not so last year. So what's happening weather-wise, climate-wise? Are we seeing a climate shift, or is this just an anomaly for Oklahoma? Gary, I may let you take that one.
I think the early cold last year was more of just a natural variability and anomaly. But maybe that early ice storm was a bit of a weird pattern. It was certainly the biggest ice storm we've had that early in the season, Halloween week. And it was a pretty damaging ice storm. So certainly extraordinary there. But, after we got that cool weather, it was actually warmer than normal for much of the winter months, much of the fall and winter months. Nothing unusually warm, but until that February deep freeze event that we had, we were actually running a little bit above normal for the cool season in Oklahoma, which was to be expected because we were experiencing a La Nina event down in the equatorial South Pacific, which tends to bring the southern tier of the United States a little bit warmer, a little bit drier than normal weather. So we were sort of in a La Nina event. We weren't seeing the typical impacts, at least until that February deep freeze. But the stuff that's happening earlier in the season, later in the season, that sort of thing, that's some of the stuff that the science has to ferret out and see if that is really due to a climate shift or just natural variability of our highly variable climate we have here, our highly variable weather that we normally experience here in the Southern Plains, Oklahoma and Texas, Kansas.
We know, Dr. Brooks, Will Rogers said, if you don't like the weather in Oklahoma, wait a minute. But I think they say that in a lot of states, is that just in the Midwest, or what is that to America, or is that something new that's happening?
Well, they say it everywhere because I think everyone likes to have that kind of a cute little phrase. But it is true that actually the middle part of North America, so the regions between the mountain ranges, actually do have a lot more variability in temperature and moisture than most places on the planet. The presence of the Rocky Mountains is such a big driver of large-scale atmospheric patterns that we get a lot of waves in the atmosphere that form as weather systems go over the Rockies that lead to us just having a more inherent variability than most places on the planet. There just aren't places that have that long, wide, high range of north-south mountains. And so that makes us more variable than a lot of places, which in some sense, some of our discussion about climate change are inherently more difficult in the U.S. simply because of ability underlying everything. If you're in a place where climate or the weather isn't very variable, then you can see trends a lot more easily than we can in the middle part of the U.S.
We do notice the extremes, of course. That's how us folks here in this part of the world notice climate change. If we have a big extreme like the 2011 heat wave, where the state of Oklahoma had the warmest summer on record, not only for Oklahoma, but for any state on record based on the statewide average through the June through August period. So we have that happen. And of course, like, wow, something's going on there. But if we look since the 70s, our winters have warmed a little bit, and we've gotten a little bit wetter during the winter. Summers haven't really changed a whole lot. But if you go up to parts of the northern parts of the northern hemisphere, where the changes up in the Arctic region are so rapid, they don't have to have the difficult time studying what's changing because it's happened so rapidly up there. So
this next question, I'm going to let you guys flip a coin as to who gets to answer it. What is global warming?
I got a coin. Well, okay. The global warming has been caused primarily in the last century or so by the increase of what we call greenhouse gases in the atmosphere, by gases that absorb outgoing radiation. They don't do anything to the incoming radiation for the sun, but the Earth radiates away just like everything does. And some of those, particularly carbon dioxide and methane, absorb that outgoing radiation and essentially rewarm the surface. We measure that the carbon dioxide has gone up. We know that it's because of burning of fossil fuels, because the kinds of molecules, the isotopic concentration of the molecules is associated with really old carbon from fossil fuels. And we've directly measured here in Oklahoma at the Atmospheric Radiation Measuring Project from the Department of Energy in Northern Oklahoma. They've done the very first direct measurements of carbon dioxide absorption raising the temperature. And so we know those things. We know those things are happening, and that's the global temperature. One of our challenges in climate has to do with the fact that most people don't really care, and in fact, I don't know of anyone who actually cares that the global temperature has gone up by a little over a degree Celsius or 2 degrees Fahrenheit in the last 100 years. What we actually care about is how that translates to day-to-day weather. And we know, for instance, that the northern polar region has warmed much more rapidly than equatorial regions. We know that winter temperatures have warmed more than summer temperatures. Overnight temperatures have warmed more. And all of these things go together with the fact that we're trapping outgoing energy more effectively than we used to. And that pattern is what you expect from increasing greenhouse gases. If it was the sun had changed, we'd see different patterns in the way the temperatures have changed. And so we know everything we know says that this is the pattern you would expect. Temperature is pretty easy in some sense, easy to explain. Mm-hmm. The thing that also we really care about is what happens with other kinds of weather events. Precipitation, essentially the water cycle in the atmosphere becomes more intense. So you can get you get heavier rain. You can also get more prolonged drought at the same time. All those things actually go together because the water system is processing faster. We go further down the road to things like hurricanes, severe thunderstorms, winter storms. It gets a lot more complicated to figure out the physical linkages that go along to lead to what might be changing there.
Mr. McManus, I want to ask you something. And the warming, I just feel like things have gotten cooler. We talk with my friends, global warming, global cooling. But that's wrong, right? Our perceptions may be incorrect, right?
Yeah, I don't know too many places that have gotten cooler over the last 50, 60 years. A little bit of a cooling trend over in the southeast due to increased precipitation, but that has started to wash out, and they've even started to warm. So in Oklahoma, our big cold events during the winter months have started to decrease, even though I know we had the thing in February where we got drastically cold for a long time. Again, that was a singular event. As long as it gets dark for 24 hours a day for a long period of time in the Arctic Circle region, we're going to get cold air, but it has started to warm up. Now, our summers haven't really warmed as much. Our winters here in Oklahoma have warmed. Our overnight temperatures, our low temperatures have risen over time. So that is a misconception. We haven't gotten colder. Again, if you took somebody that was living in the 1970s and you transported them suddenly up to the 2000s, 2010s, early 2020s, they would say, wow, this is drastically different. When I grew up in Northwest Oklahoma, I remember the farmers having to go out and bust up their stock tanks, break ice on the ponds. They don't have to do that nearly as much, if at all, anymore. So it is a misconception. We think of, well, we had the big snows. Well, we had the big ice storms. We had the big freeze event with the big snows this year. But like Dr. Brooks was saying, when we increase the energy involved in the atmosphere, and also the amount of evaporation that's going on, the transpiration that's going on, we rev up that hydrologic cycle. We rev up the weather producing mechanisms in the atmosphere. So it's more of a hydrologic cycle on steroids. So when if we get cold air associated with some precipitation, well, our chances are increase a little bit that we're going to get a little bit heavier snow. We're going to get a little bit heavier ice storm like we saw during the 2000s, where we had 8 or 9, maybe even as many as 10, catastrophic ice storms hit the state. Yeah. So when we're talking about different things occurring, when you start to increase the energy and the moisture in the atmosphere, the big snows will still come, the big rains will come, but it doesn't necessarily mean that we're seeing a cooling going on. It's just, those are normal things we would expect to see with increasing precipitation intensities with increasing frequency.
Well, listen, I want to thank you so much for your time.
Welcome.
It's really good information, and it's great to get it from experts like the both of you for the state of Oklahoma. We appreciate it very much. Good to know. Thank you both.
You're welcome. Have a good day.
You're welcome. Thank you.